Good morning and welcome to GWA Physics. Today I want to talk a little bit about pulley systems and try to get this to be something that's easy for you to understand. First of all, let's draw a picture of some things that we knew from an earlier chapter that should make some sense. Remember when we learned about the concept of tension? We had an object that was hanging by a string, and we said that if the weight of the box, the F of G, was equal to 100 newtons, then the question was, what was the tension on the string?
I gotta go to that meeting. I'll see you later, thanks.
The tension would have to be equal to 100 newtons also, because it was being supported by a single string. If you take the same box and you support it by the weight by two strings, then the weight in the down direction would be 100 newtons. But now each of the strings is holding a fraction of the weight. And because there's two strings, this one would be 50 newtons and this one would be 50 newtons. And we could go on and on. Let's go one more time. Suppose that the box was being held by three strings. Then the weight of the box is still 100 newtons. But now each of the strings holds 33. And that should make pretty good sense. Now, if I change colors right quick, let's look at the pulley systems and see how this compares. When you have a fixed pulley, you've got the pulley attached here like this, and you've got the rope going over the pulley, and there's the object, and we're pulling on this rope to make that one go up. On a fixed pulley, if this is 100 newtons, then it's being supported. If we look at this diagram right here, it's being supported by a single rope. So 100 newtons is going to be supported by a single rope, so the tension on the rope is 100 newtons, and so therefore we're going to have to pull down with a force of 100 newtons. So it's a 1-to-1 ratio on a fixed pulley. And one of the things that we learned about a fixed pulley is that the mechanical advantage is to change the direction of the motion. So when we pull down, the object goes up. Now, let's look at the next type of pulley. The next type of pulley, the rope is attached and the pulley is free to move. And so this pulley system is called a movable pulley. A movable pulley has a little different setup here because when we pull up on the rope, the box also moves up. Whereas if you look back at this one, when we pulled down, this one went up. So these were moving in opposite directions. This one's moving in the same direction. When we pull up on the rope, the box moves up. But something else that you need to see that makes sense, if you look right here like this, and you saw that you showed me, I asked you to watch this on another video from another teacher. Notice that the box is being supported by two ropes. And so you've got the rope on this side supporting part of the weight, and you have the rope that we're pulling up on supporting part of the weight. So if this is a 100 Newton box, here, this rope holds 50 and this rope holds 50. So now you can see that the movable pulley has a mechanical advantage of 2 because it's twice as easy, but the other part of it that we need to remember is he's going to have to pull the rope twice as far to get the object to move. Now, if we look at a block and tackle, which is the next kind of pulley system, there is a fixed and a movable pulley. And the setup looks like this. the weight that we're carrying is here, and we're pulling down in this direction there. In a simple single block and tackle, let me write that right here, block and tackle. In this block and tackle, again, you can see that the weight is being supported by two rows. So if this is 100 newtons, this one holds 50, and this one holds 50, and then the purpose of the fixed pulley at the top is to change the direction of the force. And so in this situation, a simple block and tackle is a 2-to-1 ratio. Are there any questions about that? Thank you for watching. There's going to be a part 2 that shows some of the more advanced ones at the next video.